Today we will discuss about gas transport and pH in topic respiration. Okay. The first thing we will discuss about the gas and reaction of hemoglobin and oxygen. Hemoglobin plus oxygen reaction. We will first look on this topic. Okay. Before going to discuss about the reaction, we will first discuss in a very short about the formation of hemoglobin. Okay, hemoglobin is formed generally it consists of a porphyrin ring. As we all know that four pyrrole rings combine together to form one porphyrin ring. Okay, and this porphyrin ring combine with iron to form heme. Okay, and one heme when binds to a polypeptide chain will form alpha or beta, and 2 alpha and 2 beta will form the protein hemoglobin, that is. Okay, it means that hemoglobin contains 4 heme group. Okay, and this 4 heme group will bind to 4 oxygen molecules, that is 8 oxygen atoms. It means one heme group will bind to one oxygen molecule. And one more thing I need to mention here, that this bonding between iron and oxygen molecule is not a covalent, not ionic. This is only a simple coordinate bond. As we all of us know that ionic and covalent bond are stronger than coordinate bond. So coordinate bond is weaker, and this will facilitate the dissociation of oxygen from the hemoglobin. Okay, this was the part. And when hemoglobin reacts with oxygen, it will undergo oxygenation. But it will undergo oxygenation. It will not undergo oxidation. Oxidation involves the change in oxidation number of iron, but here oxygenation will occur. Iron will directly combine to oxygen molecule and not the changing the oxidation step out of the iron. Okay, iron will remain same, Fe+2. Okay, and how will be the reaction will occur? See here, this is the hemoglobin O2 bind with, this is the reversible reaction. Okay, the first heme group will bind to one oxygen, form Hb4O2, then again it will bind to one more oxygen, it will leading to formation of Hb4O4. आगे क्या बनेगा Hb4O6, and again it will form Hb4O8. Okay, and one of the most important thing is that the reactions involves the idea of cooperative binding. In enzyme, in biochemistry, you will read about cooperative hypothesis, what it will tell. Okay, it means that when the first oxygen bind into hemoglobin, the affinity for the upcoming oxygen will increase. Okay, for upcoming oxygen the affinity of hemoglobin will increase. This is the most important thing. Okay, and the very important concept that hemoglobin is a quaternary protein. Okay, it has 2 configuration generally. The first configuration is T configuration, and the another configuration is R configuration. Okay, what means T configuration? You are thinking about what will be the meaning of T. T means simple tensed configuration. Okay, tense configuration. R means opposite, relaxed configuration. Okay, the tense configuration, the relaxed configuration. As the name itself suggests that hemoglobin is in tense condition, so it will not bind oxygen more efficiently. It is in relaxed condition, so it will bind to oxygen more quickly. Okay, just think, when a person is in very tensed condition, he is not able to do anything very efficiently, but when he is in a relaxed condition, he is able to do and perform the same work more efficiently. Okay, like this. What means tense configuration? It means that the globin units from which the hemoglobin is formed is tightly packed. Globins are tightly packed. Globin units are tightly packed. Okay, and in relaxed condition the globin units are not tightly packed, it is loosely packed, so allowing more oxygen diffusion to the heme. Okay, when the globins are tightly packed, there is very little space through which oxygen can reach to the heme group. When the first oxygen binding to when first molecule of oxygen binds to the hemoglobin, it will lead to the change in configuration, interconversion of the configuration from T configuration to R configuration. Okay, and thus leading the increase in affinity of the hemoglobin for the binding of oxygen, as I have told earlier. This was the basic reason behind this. Okay, and the increase, how much time the binding will increase when the first oxygen bind is at a 500 fold. Okay, 500 fold increase in oxygen binding when the configuration changes from T configuration to R configuration. And if we are talking about one RBC molecule, one RBC cell, okay, then it will undergo 10 to the power 8 times transitions, that is from T to R, R to T, T to R, 10 to the power 8 times during its life cycle. RBC has life cycle of 120 days, as we know, and in this 120 days it will undergo 10 to the power 8 times transition from one configuration to another configuration. Okay, are you getting my point? Next, moving to the oxygen hemoglobin dissociation curve, which is a very important topics, quickly asked in your semester examinations. What is the curve? The curve, first of the curve is sigmoid curve. Okay, and the reason for this sigmoid curve is the TR interconversion. There will be no straight curve because due to TR configuration, the sigmoid curve का reason पूछा जाए आपसे तो क्या बताना है? TR configuration. क्यों? Why this TR configuration? Because we have seen that when the first oxygen molecule binds to the hemoglobin, the affinity of hemoglobin for the upcoming oxygen gets increased, and we have discussed here 500 folds. So there is no linear relationship between the oxygen binding and hemoglobin affinity for the oxygen. Okay, in ideal condition, say that when hemoglobin is 100% saturated with oxygen. Okay, in this condition, when fully 100% saturation is there, in that condition 1 gram hemoglobin generally contains or carry say 1.39 ml of oxygen. I am talking about ideal condition when 100% oxygen is present in the 100% hemoglobin is saturated with O2. There is no binding of hemoglobin with other things. Then 1 gram hemoglobin carry 1.39 ml of O2. Okay. However, blood normally contains some quantities of inactive hemoglobin derivatives. Blood normally contains some hemoglobin are in inactive forms. Okay, some hemoglobins are always in inactive forms. Okay, and the measured value is thus slightly lower than 1.3 ml of O2. Okay, and that you have read in 12th standard, that is 1.34 ml O2. Okay, that I am not going to 1.3. 1 gram will carry 1.3 ml oxygen. Now how many? Okay, and we are knowing that the hemoglobin concentration in normal blood is about 15 gram per dl. Okay, and talking separately about the in male and female, 14 gram per dl in women and 16 gram per dl in men. Okay, this type of, therefore 1 dl of blood contains 1 dl of blood, 1 ml of blood contains 21 ml oxygen. How? Because we are knowing that 1 gram is carrying say 1.34 ml oxygen, and 15 gram will carry 15 into 1.34 ml, and this the value comes 20.1 ml oxygen. Okay, but in vivo, the hemoglobin in the blood at the ends of pulmonary capillary is about 97.5% saturated with oxygen. Okay, not 100% saturated. What is the reason behind this? What is the reason behind this? That is, it is 97.5% saturated, not with 100% saturation is there. The reason is that, reason is only that physiological shunt. What is the reason? Physiological shunt. In detail I will discuss in the later on. I will discuss about the physiological shunt, but keep in mind that the saturation is lesser because of the presence of the physiological shunt, that is a slight mixture with venous blood that bypasses the pulmonary capillaries. Okay, thus the arterial blood therefore contains a total of about 19.8 ml oxygen per dl. Okay.